I'm going to write in a different color because I feel like there's a lot going on here, so I want to make sure you know what I'm adding in. So I'm going to use my green marker pen so you can tell what I am writing down. So we're going to go through some different transformations today. Typically in years past, when you've learned about transformations, you've learned about them with a specific function type. So for example, you've learned about quadratic equations and then you've done transformations just on quadratics. Today it's a hodgepodge of every type of function you've ever learned about. So we're going to talk about transformations, but with anything, okay? And so we're going to go through and I'm going to remind you of what they are. Now, you know I'm a very type A person and I like stuff like neat and organized and all the things, right? So in the columns, I've got what we're doing, an explanation, and then we're going to do a specific example of each one too, because I feel like it really does help to be grounded in a specific example so you know what it looks like. Alright, so horizontal translation left. Remember that these can also be called a shift. So you might hear the word shift, and that just means we're taking our graph and we're shifting it to a new location. We're putting it in our graph moving van and we're driving it to a new spot. Now, a horizontal shift left. Think about what that would look like. So if I move to the left, typically that direction is what? Negative. Your graph compensates for it though. So you actually put in the opposite of what you would think. So if you were going to shift left 4, it's actually going to go in as +4. Also, because it's something that's impacting you horizontally, it's going to go right in with x. So when I write my new equation, first of all, I'm going to switch the name. So anytime you undergo a transformation, you're going to switch the name of your equation. You don't have to call it g of x. You can call it h of x or whatever you'd like to call it, but give it a new name, okay? Because we are doing something to it, so it's a new function. So if we want to translate left 3, again, horizontal stuff goes right in with x. So it's going to go right in there in that absolute value. And again, if we're thinking left 3, we think, oh, that's the negative direction, but the graph compensates. So it actually goes in as +3. Good? Okay. Function notation. So this is just kind of a more generic way of writing it. We took our f of x, and in parentheses, we added 3. So this is just basically another way to describe what we did. So this is saying it in words, this is saying it in function notation, and then this is the actual example of me doing it. Does that make sense? Perfect. So horizontal translation to the right is almost the same thing. It almost doesn't even preserve its own row of stuff, right? Because we're going to do almost the exact same thing that we just did. So going to the right, we would think would be positive, but it compensates and does the opposite, so we're actually going to do negative. So g of x equals square root, and it's going to go right in there under the square root with the x. If we want to go right 10, what should I put? -10. So what I did is I took my f of x, and I subtracted 10 right in there with all my x values. Good? Vertical translation up. So translations up and down are a little bit easier. They just get added on to the end. Okay, so if I have this quadratic equation, literally I'm going to take this quadratic equation and just add it on. Now, do you notice that I have like terms that I can combine? I am going to do that and simplify. So g of x equals 2x squared plus 5x plus what? 5. Yes. So I took my f of x and I added 12. So the plus 12 goes outside. Now somebody asked this question last hour and I thought it was a good question to ask. They said, go back to the other problem for a second. So the square root one. They said, where would the 12 go? Would it go under the root or not? What do you guys think? No. So if I wanted to go back here, let's say this was my equation and I wanted to shift up 12, the plus 12 would come outside. Does that make sense? So it's kind of like an afterthought. It's like an add-on at the very end when you're shifting up or down. And again, you can combine it with any other like terms that are there, but I thought that was a really big question, so I want to make sure I said it again this hour. Translation down is almost the same thing. We're just going to subtract. Is there any like term I can subtract from? No, bummer. G of x equals x cubed minus 16. And then my function notation, I had f of x, and I moved down 16. So sometimes they will ask you to also give the function notation, or they'll tell you the function notation instead of writing it out in words, so that's why I'm kind of giving you both. Does that make sense? So typically you won't have both of these things involved in a problem. You'll get one and be asked about the other. So I just want to make sure you can associate the words with what the function notation looks like. Okay, every year I say I'm going to fix this worksheet, and it hasn't happened yet, and it's year 18. So maybe year 19 is the year. I flipped what it should say here with reflection over the y-axis, which is kind of apt because it's reflection. But we need to fix it. Ready? Okay. Go ahead and draw out a graph for a second, and I want you to think about what a reflection over the x-axis actually looks like and is. So let's just take one easy point and reflect it. I'm going to go with the point 2, 1. So there's 2, 1. If I reflect it over the x-axis, where is it going to live? Below. What's the new location? So this was 2, 1. What's my new location? 2, -1. So what changed? The y value. So we are going to impact the y value. So that's what it should say here instead, is that we are going to impact the y value. And it's going to, in turn, change all the signs in our equation. Changes all signs. Okay? So remember that f of x, g of x, all these things are a fancy way of saying y. So if we are impacting y, we need to impact all of what y is equal to. And that's why they all change. So for this one, my new equation would be g of x equals, and we're changing all the signs, -2x squared minus 8x minus 4. So what did we do? We basically took our f of x and we put a negative out front. We kind of distributed a negative through. So again, if your y values are being impacted, that means all of what y is equal to should be impacted. So that's why we're changing all the signs of g of x, because again, g of x is a fancy way of saying y. Good? Okay, flip when you're ready. I'm going to give one more second in case people are still writing. Okay. Here we go. So this one's wrong too, because again I switched it. So you can cross this one out. We're going to switch this too. Alright, so what happens when you reflect over the y-axis? What do you think is going to be impacted? The x value, right? So x is impacted in this situation. Let me see what my verbiage was. I said, what did I say? Each x, I didn't say each x, but I'm going to say it that way. Each x picks up a negative. So only the x's. And it's going to go right in parentheses, just like it did when we were doing the horizontal shifts left and right. Okay, so it goes right in with parentheses. Goes in parentheses. So if there's an x, it goes right in there with the x. So it needs to be grouped in there with the x. Good? So let's look at the example. So over here, I'm going to say g of x to give it a new name. I'm going to put the negative right in with the x. Now, do you see how the negative goes in with it before anything else happens? So before I think about cubing, before I think about multiplying by 4. So the negative has to happen first. Plus 8, and again, I'm going to put the negative right in with the x, minus 10. So I think I just hate the word isolate because of the pandemic and everything that word meant during the pandemic, but that's truly what you're doing, right? You're isolating x in a set of parentheses when you've got horizontal stuff, and the negative's going to go right in with it. Now, I do want you to simplify this. So this will say g of x equals, if I cube this, negative x cubed is it going to come out negative or positive? Negative. So this is going to come out negative 4x cubed. Remember, a good rule of thumb to think about is if it's odd, it's going to come out negative in terms of your exponent, right? And if it's even, it'll come out positive. Negative x times 8 is going to give me negative 8x, and then I've got my minus 10. So in terms of my function notation, what did I do? I took the negative and I put it right in there with the x. Questions on that one? That one's a little bit trickier. Now we're good? Okay. Alright. Vertical stretches and compressions. Anytime I see vertical stretch or vertical compression, I think distributing. So vertical stretches and compressions are exactly what they sound like. You're taking something and you're either stretching it vertically or compressing it vertically. Okay, I almost think of like my visual that I get in my head is like the funhouse mirrors at the fair, right? Like you go stand there and you look like silly in the funhouse mirror. That's what I think of when I think of stretches and compressions, because it's making it look distorted in some way. And again, think distributing when you think vertical. So if I'm going to vertically stretch by 4, literally I'm just going to multiply everything by 4. So my new equation would be 20x plus 8. So what did I do? I took 4 and I multiplied it to my f of x. So that would be my function notation that's associated with it. And then the same thing for a compression. This one only has one term, so it's even easier. G of x equals 1/3 x to the 4. So what did I do? I took 1/3 and I multiplied it by my f of x. So again, think distributing when you see vertical stretches or compressions, that number gets multiplied to everything that's a part of your equation. Next. Horizontal stretches and compressions are a little bit trickier. Remember a minute ago when we did the shifts? Right? And we shifted left or right and it went in as the opposite because the graph compensated? The same thing happens here. We've got a compensation thing going on. So what's going to happen is that when you are going to stretch horizontally by 4, you're not going to multiply by 4. You're going to multiply by the reciprocal. So if you're thinking, well, 4 isn't a fraction, could I turn it into a fraction by putting it over 1? Yes. So then if I took the reciprocal, it would be 1/4. So how do you rewrite it? G of x equals. This is very similar to what we did with the negative when we were reflecting over the y-axis, where we're going to isolate the x. So again, whenever you're doing something horizontally, you can always think about isolating that x. So do you see how the essence of the equation is still there? The 2, the x, and the minus 3? Okay, so I am only impacting the x because I'm impacting it horizontally, and I want to do a stretch by 4. Again, we multiply, though, by the reciprocal. So it's going to be 1/4. And then I am going to simplify this. So g of x equals, this would give me 2/4, which is really 1/2. So g of x equals 1/2 x minus 3. So what did I do? I took my f of x and I multiplied it by 1/4. Next one, we want to compress vertically by 1/3. So what am I actually going to multiply by? 3. Okay. So again, we're going to have our x squared still exist, but we're going to kind of isolate off the x. And so this is going to go in before we even square it. Plus, And this one doesn't really need the isolation, but I'll do it just to really drive the point home. And the 3 would go in there as well. And yes, I do want you to simplify here. G of x equals 9x squared plus 3x. Don't forget to square the coefficients of 3 and also the x. My function notation, what did I just do? I took f of 3 times x. Yeah? Oh yeah, and I have that in my notes. Thanks, brain. Compress horizontally, yes. I have it crossed out in my other copy, but I didn't have it here. Yeah. My verbiage over here didn't match. Thank you. I just need to get like a little sign that I can hold up when you fix things that says thanks, brain, every single time. Somebody needs to make me a sign, like on a popsicle stick, that I can, like, you know what I mean? Just hold it up. Okay. Let's flip to the back. Alright, we're going to talk about a couple things. The first one's going to be graphing. And we're going to think about how we can graph using the idea of transformation. Now, before we graph this, I want to think about the parent function. Remember that the parent function is the most simplified, toned-down version of the function that exists. Okay? So the parent function for this equation would be just the square root of x. Because can I make it any simpler than that? No, right? And still keep basically the essence of the equation that it is a square root. I'm going to graph this first. Should I plug in negative numbers? No, because then I'll get out imaginary values and I'd have to graph in the complex plane, and that's a whole other thing. So we're not going to do that. So let's plug in numbers that'll keep it real. Let's also plug in numbers that are nice, right? Like, why make our lives tough? Let's plug in nice numbers. I'm going to plug in 0. I'm going to plug in 1. I'm going to plug in 4. 9 would be another good number to plug in, right? So if I plug these in, square root of 0 is? You can say, yes. Square root of 1 is? And square root of 4 is 2. So I have a point at 0, 0. I have a point at 1, 1. I have a point at 4, 2. Often throughout the year, you will notice that I like to be the graph and show you with my person what the graph looks like. I call this the I'm a little teapot graph because I feel like it's what I look like when I'm the graph. Right? So this is the I'm a little teapot graph. So if you ever hear me say that, that's what I'm talking about. Okay, so that was our parent function. Now, let's go back to what we actually had. There's a minus 2 and it's underneath the square root. What do you think that's going to do? Yeah, well, more than 1, right? It's going to shift everything 2 to the right. So instead of making a new table, again, it just wants me to graph by applying the transformation. So I'm going to pick up each point and slide it 2 to the right. Slide it 2 to the right. Slide it 2 to the right. So if you come across a question like that, that's what it's asking you to do. It's asking you to think about the parent function and what that graph looks like. Then think about the transformation and then graph accordingly without making a second table. Alright, next, what happens if we have multiple transformations? So I kind of think about this in respect to if you're asked to do something. So let's say you go home from school today and your mom says, hey, can you put away the dishes and do the laundry? That's a lot of stuff. But let's say that she asked you that. Does it probably matter what order you do it in? Right? If they get done, she's happy. So here, when I tell you to do things like shift up and go left 4, you have to do them though in the order I say them. Because it's a math thing and not just an everyday life thing. And remember, order of operations really do impact us. So we do need to do them in the order they're given to us in. So, start by shifting up 3. If I had x squared, what would be my equation but shifted up 3? x squared plus 3. So start there. Always do that first and then keep reading. I also want to go left 4. Okay. Let me rename my equation. Again, I'm going to give it a new name because it's a new thing. What am I going to do differently to make it go left 4? I need a parentheses x plus 4, and then my plus 3, and what else should still be there because it was quadratic? The square needs to be up here. These I don't care if you simplify. I mean, if you want to, go ahead. This one doesn't really impact me. The ones that I like you to simplify are when you have like single terms in parentheses like this. So these I like you to simplify so you don't have a bunch of single parentheses. This one I don't care as much about. If you're going to have trouble remembering when to simplify and when to not, just always simplify, right? FOIL it out, add the 3. Next one, we want to vertically stretch by 7. Let's do that first. So I'm going to take 7 and I'm going to multiply it to x cubed. Again, because it's vertical, it goes out front. Now I'm going to read the second part. I also want to reflect over the y-axis. Is that going to impact x or y? It's going to impact y. Remember, it impacts the opposite variable. And so if it's impacting y, it impacts all of what y is equal to, so it switches all the signs. So I go from a positive 7x cubed to a negative 7x cubed. Good? All right. The given graph is the one that's highlighted. Okay, so that is my absolute value graph. I call it the Flying V graph, but you guys don't know that movie anymore. Do you know what the Flying V comes from? Anybody? The movie. The Flying V, the Disney movie. Lady Ducks? Anybody's a hockey one? Okay, I'm too old. Got it. Okay. Anyway, we've got the Flying V graph. If this happens, what would we call that? That's a what? It's a reflection over which axis? X-axis. So what would my new equation look like? So this is my original. How's the new one going to change? Negative out front. Good. So the negative goes out front because, again, it's impacting, if it's a reflection over x, it's impacting y, so it needs to go out front. How are we doing so far, okay? Okay, last thing. Our functions that we encounter in life can be even, odd, or neither. And we have ways to figure out which category they fit into. So let's start with even. So there's a little test that you can do algebraically to decide if something is even, odd, or neither. So let's start even. If you find f of negative x, and it is equal to f of x, then that is an even function. Graphically, what you're looking for, so graphically, like visually, if you're looking at the graph, what you're looking for is that the graph has symmetry to the y-axis. So those are two different ways to tell. So you don't need to think about both at the same time. These are two separate ideas. So again, if you want to think about it in terms of the algebra, you can plug in a negative and see if it comes out the same. If you want to think about it graphically as a picture, then you would look at the graph and see if it had symmetry to the y-axis. Here's a graph with symmetry to the y-axis, yes? Because it looks the same on both sides. All right, what if it's odd? What's the option there? So odd is our other option, and that is if f to the negative x equals negative f of x. In terms of how it looks, it's 180-degree rotational symmetry to the origin. Remember, the origin is just 0, 0. So a graph that's odd would be like the graph of y equals x cubed. Do you see how if I picked up this graph and rotated it 180 degrees about the origin, it'd land right back on top of itself. Or we call it mapping. It'd map back right on top of itself. That's what that looks like. Okay, so let's go ahead and look at these, and we're going to decide algebraically. So we're actually going to plug in the negative. Now, neither is an option as well. So if you don't have symmetry to the y-axis and you don't have 180 degree rotational symmetry to the origin, then guess what? It's neither. If neither of these things come up, then again, it's neither. So neither is an option. All right, so how do we do this? We plug in a negative, and we see what happens. Is basically, it's like a little experiment. What happens if I plug in a negative? And again, you're plugging it in right in parentheses. So if it turns out to be the same thing, it's even. If all the signs switch, it's odd. If it doesn't do one of those two things, it's neither. All right, negative x to the fifth. How's that going to come out? Negative x to the fifth, right? And then this is going to be negative x. How did your signs change? Did they both change? Yeah. So if they both changed, that's fitting with odd. So this is odd. And if you wanted to double check, you could always put it into your graphing calculator and check and make sure it looks like it has 180 degree rotational symmetry to the origin. Let's try the other one. Again, our test is to plug in a negative with the x. Again, right in parentheses, right in there with the x. If I take negative x and raise it to the fourth power, how is it going to come out? Positive. So I still have my 1 minus, and this is going to come out as positive x to the fourth. How does this equation compare to the original? It's the exact same thing, right? So this would be even. And again, odd would be some combination where maybe some things change signs and some things didn't. Right? Or sorry, what did I say? Odd. Neither would be a combination where you have some things changing and some things not. All right, assignment number 6. It went pretty quick for second hour, I feel like. Hopefully you guys will feel the same way. Page 187 to 189. Numbers 5 to 7, 21, 27, 45 to 52, 55, and also 75. Good? Okay, I'll put the music on. Thank you for